Hey there, Patriots. So in this video, we're going to talk about the volume of geometric solids. So I'm going to introduce you to the definition of what a volume is, and then I'm going to introduce you to all the different volume formulas that we can use. So what is volume? Volume is the amount of space inside any geometric solid. So I'm going to make this kind of bigger to speed things up. So volume is how much space will this cylinder hold? That's volume. Volume is how much space is inside this pyramid. Volume is how much space is inside this sphere. So volume is space that my solid occupies. How much space will that solid hold? Now, if I give you a prism, we can always find the volume of a prism the same way. Volume, the amount of space inside. What we need to do is we are going to find the area of the base. So you're going to pick one of the bases, I don't care which one, and you are going to calculate the area of that one base. I don't care which one base it is. You can do this base or the back base. You can do the bottom. You can do the top. It really doesn't matter which one. And you will multiply that by the height of the prism. The height of the prism is the length between the bases. And I always like to use the one that they've labeled. All right, because all the heights are congruent. So that's something nice to remember. All heights are congruent. And then remember, both bases are congruent. So it doesn't matter which base you pick, and it doesn't matter which height you pick. They are all congruent. So you and remember, so this one, the area is going to be for a trapezoid. Here we have to do the area of a triangle. We're actually going to do those in class, so I will hold off on the video on how to do them. Well, sometimes if I give you a rectangular prism or a cube, there's an actual easier formula. You can use the volume formula. It really doesn't matter. Or if you can recognize that, hey, look, this is a square on the bottom or a rectangle, so I can multiply the length of that square or rectangle by the width of the square or rectangle, and then multiply that by the height of the prism, the distance between the bases, and that will also give you the volume of these prisms, because length times width equals big B. So when we're looking at this, length times width equals big B. So I'd still have big B times H, but this just makes it a little easier sometimes. If we have a cylinder, what we are going to do is we're going to do pi r squared, because again, pi r squared equals big B. So that's an easier way of doing it. Is this formula. You can still use big B times H. That works. Or you can say, hey, take the radius of the circle. I just need that distance there. And then I need the height of the prism, the distance between those two circles, and plug it into our formula, and we're off to the races. Now, pyramids are different. Now, because pyramids don't go straight up and down. Remember, they come up to our apex. They come up to a point. So again, we are going to find big B. So we're going to find the area of the base. Got to find this area. Or this area, depending on the shape. Depending on the shape, you're going to use that formula, and you're going to find the area of the base. And then we are going to multiply that by the height of our prism. Now remember, the height of the prism, that's not slant height. That's the distance between the base and the apex, or the vertex. The distance between the apex and the center of the base is the height of my pyramid. And notice then we're going to divide that whole thing by 3. Because as it slopes in, it only has 1/3 the volume of an associated prism. It's kind of cool. If I give you a cone, Remember, pi r squared, that's big B, so I could use the formula for pyramid, or I could just make my life a little bit easier. I'm like, hey, let's take the radius of the circle. Now remember, radius is half the diameter. I'd only use half of that diameter. And I'm going to multiply it by the height of the cone. The height of the cone is on the inside, not like with surface area where it was slant height. It is actually inside that cone. Plug it into 1/3 pi r squared h, and you're going to have the space inside that cone. Now, pyramid and prism fun fact. If a prism and a pyramid have the same base area, notice this base area, they're both circles with a radius of 5, so their base areas are the same, and they both have the same height. The volume of the cone is 1/3 that of the cylinder. What I am saying is it takes 3 cones to fill this cylinder. And not only a cone, it would be any pyramid. It takes 3 cones or pyramids. Oh, goodness. Oh, let me jump back. To fill a let's go to fill a prism with same base and height. There we go. That's how I want to say it. So if they have the same base and they have the same height, it will take 3 pyramids to have the same volume as that one prism. Kind of a fun fact. I like it. What if I've got a sphere? Spheres are easy. To find the volume of a sphere, I am going to do 4/3 pi radius cubed, where of course radius is the length of the radius in units, whatever these units are. And we're going to get 3 of them. That's why volume is in cubic units. And then if it's a hemisphere, again, all I need is the radius, which is the distance from the center to the edge, and I'm going to use the formula 2/3 pi r cubed. Easy enough. Alrighty, so if you got any questions, please let your teacher be aware of them so we can get them answered, and we are going to be ready for our CRT. We're getting down to it, Patriots. If school was 10 today, are you going to pass? Hope so. See you in the library at 3:30, if not.